On Saturday, November 12, 2005, over 60 volunteers gathered at the Museum of Science and Industry in Tampa, Florida, to participate in the 2005 Ride for Science research project. This unique transportation event gathered data from the participants through two activities. The first, while riding their bicycles on a 20-mile course specifically designed to include a variety of urban traffic conditions, and secondly, while viewing a number of video recordings made from a bicycle in similar traffic situations. The volunteers were asked to rate their feelings of safety and comfort by grading selected segments on a scale from A to F.
What we're doing is developing a level of service model for bicycles on the roadway. What that means is, on a roadway such as a Fowler, a 30th, or any other arterial you can think of in anywhere, we want to know how people would feel riding on it without putting anybody on the street. So in order to do that, we need to get the input of a lot of bicyclists to tell us how they would feel riding on particular types of roadways, and that's what we're going to do.
This is 10 years since the first time we did a Ride for Science. Since that time, we've created a mathematical model to accommodate bicyclists in intersections, and tomorrow, the essentially 10th anniversary of this, we'll be doing it for roadway corridors or arterials. Each one of you is very important to this endeavor. The Florida DOT will be using this information to affect how roadways are going to be built in the future, not only throughout Florida, but people will use them throughout the United States.
In order to ensure statistical accuracy for the research results, the participants were given specific instructions for the procedures for grading the 12 sections of the 20-mile course at a pre-ride briefing.
All sections on the course are to be scored, are marked with the yellow signs where they begin and end. Now when it comes to grading, you want to circle the letter grade that best describes how well you feel each section serves your needs as a bicyclist.
Okay.
Each section can be graded from A to F, with A being the best and F being the worst. Grade each section as you complete it. You can change your grades anytime.
We're starting you at 90-second intervals. When you finish the course, you'll hand the scorecard in. You're both on reverse, so you're going to go to the video afterwards. And you go.
Okay.
As part of their briefing, the riders had also been reminded to follow the rules of the road, and in particular, to obey the appropriate traffic signals while crossing intersections, to ensure that their scores would indicate their experience of each facility and intersection was as it had been designed to operate. In addition to grading the 12 sections as marked on the course, the riders were asked to stop at each of 5 time checkpoints along the route. The proctors there noted the arrival time of each rider so that the researchers could cross-reference that time with traffic data as provided by tube counters on the roadways.
There you go. Have a good ride.
One of the things that we're definitely trying to do is to promote bicycles as an alternative mode, not just for recreational use, although that is the biggest use, but also to make it available so that people can do more routine trip purposes with bicycles. One of the biggest issues we have, though, is making sure that we provide the right kinds of facilities so that people feel safe, feel comfortable riding their bikes. So what we're hoping to get out of this is an understanding of how comfortable and how safe people feel in different sorts of conditions with different sorts of bicycle facilities. This will give us some kind of indication of, in the future, as we improve roadways, what types of accommodations do we need to make for bicycles? Is it an appropriate place to provide bike lanes, perhaps side paths? Perhaps it's not appropriate to put bicycle facilities at all in this facility, and we need to look at things like maybe parallel paths that would be safer and more convenient for bicyclists.
The 2005 Ride for Science was the 4th event of its type sponsored by the Florida Department of Transportation. A significant feature of this project was the development of the video simulation recordings, which most participants had watched before riding the 20-mile course. In order to provide a control for scoring bias, about 1/3 of the riders watched the video recordings after completing their rides.
Essentially what you'll be doing is watching about a 45-minute video with 11 roadway sections. And you'll be grading these roadway sections. Are they accommodating your bicycle needs, etc.? We'll be working with an A through F scale, A being the best, F being the worst. The videographer will stop at signalized intersections. Sometimes you won't see the signal, but if you're a bicyclist, be aware that it's turning green and he's starting up. So assume that it's properly signed.
There are some roadways that, because of the volumes on the road or the trucks or the number of conflicts, we didn't feel comfortable putting riders out on those roadways in our course, but we wanted the data from those roadways. So we decided to use a video simulation, and it was very important that this video simulation have a high fidelity because we needed to capture all of the roadway characteristics. We really had 5 objectives for the video simulation methodology. The first was, of course, that it had to accurately portray all the roadway conditions that the bicyclist would be exposed to. The second was that we wanted it from the bicyclist eye view. We also wanted to make sure the overtaking motorist didn't go too far out of his way when passing the cyclist. Another operational concern we had was that people had to be able to watch the video. Experiences with helmet cams and frame-mounted cams, some of the participants got nauseous or had headaches. Our last concern was that, of course, for the safety of the people shooting the video. We had a very scripted, very specific way we wanted things shot. We wanted to make sure that the person shooting the video wasn't in danger when he was out riding on a very busy roadway.
In finding the correct methodology for the video simulation, we've tried perhaps half a dozen different combinations of bicycle camera mounts. And in doing that, we came up with a recumbent and upright bicycle combination made by Belinky, where the captain and the driver actually sat upright in the back and the videographer would sit in the recumbent seat on the front with a post-mounted camera right at the bicyclist's eye view. And from the rear, as you are a motorist approaching, you would not think that there was anything unusual about this bicyclist. So it allowed the research to be a lot cleaner, you might say, with not the effect of the motorist that would otherwise give a real wide swath to something that looked very strange or unusual on the road.
The video methodology we came up with worked very well. We did some initial pilot testing and everybody said it was the most bicycle-like video simulation they had seen. People could watch it for extended periods of time, and it worked very well correlating with the real-life scores we got on the roadway.
I think the video simulation is the wave of the future in this work. It allows us to capture conditions that are rather extreme that we wouldn't want to put live people out in. Because we're calibrating it to the real world conditions, some of the same footage in the video is actually on the course. We're able to come up with a calibration that works. It also allows us to do these type of analyses with different populations without having to put people on the roadway again. We're real excited about the video.
After riding the course and viewing the video simulation recordings, the participants were asked certain questions to provide more information about the reasons for their choices in grading the roadway sections.
What do you consider the 3 primary factors that influence your feelings of how well sections meet your needs as a bicyclist?
Say the width, like having the width of the shoulder for the cyclist to travel on.
Width of shoulder for cyclists, okay.
The maintenance of it.
Okay.
And I guess traffic to some extent.
Okay.
B was, let's see, I would say good roads for riding with light traffic.
And then you have a number of F's over here. What made you say it was an F?
Those were the ones where you're like biting your teeth, your nails trying to go down.
Biting teeth?
Biting nails, actually.
Biting nails. That means you were afraid.
They were right. There was no bike lane, no shoulder.
No bike lane.
No shoulder.
No shoulder. Not fun. No shoulder. Okay,
High speed.
High speed drivers.
Right. And you were just like, oh, please get me off this section.
Gotcha.
Using the results from the 2005 Ride for Science and other prior projects, the researchers were able to develop a highly reliable, statistically calibrated level of service model that accurately represents bicyclists' perceptions of arterial roadway facilities.
This model includes two major components: the conditions within the roadway segment and the number of conflicts per mile that bicyclists have with motorists from side streets or driveways. In the segment environment, those factors that affect bicyclists are things such as the effective pavement width, which includes the width of the outside lane plus a shoulder or bicycle lane striping, traffic volume, the speed of that traffic volume, the type of vehicles in there such as percent trucks, and also the pavement surface condition. The second component, that of the conflicts per mile with motor vehicles, is simply measured by the number of unsignalized intersections per mile. The resulting mathematical model is applicable throughout the United States. This model can be used by transportation planners and engineers to not only reflect how the conditions are currently, but also what kind of changes can be made in the environment to better accommodate bicyclists. This project also confirms for the first time that it is possible to use a moving camera or moving video platform to simulate actual bicycling environments. This kind of tool now enables researchers to explore many other situations and test different kinds of designs to better accommodate bicycling in the urban arterial environment.
We get a lot of requests from citizens groups, and public officials a lot of times to come in and put certain types of bicycle accommodations on certain types of roadways. For instance, there's a frequent request for bike lanes themselves. This will give us the information to go back to government officials and to citizens groups and say, yes, we believe this is a good idea, how can we go about pursuing it? Or to say that this is perhaps not the safest and best idea for meeting the needs and desires of bicyclists. Let's explore other alternatives that may be safer and that may provide us just as good a way of meeting their needs.
We now have a wonderful opportunity, I think, to incorporate so much of the findings of the research we've been doing over these past years with multimodal level of service and take that information and begin to incorporate that into the design, the planning, the construction of a roadway system that really serves the needs of the people of Florida.